So in this video, we're going to extend on the last one that we used to figure out what the equation of the tangent line to the graph was with the point slope form. And we defined that to be t of x equal to this in general. So another line besides the tangent line is the normal line, okay? And so what does the normal line do? It's perpendicular to the tangent line, okay? Therefore, the slope of the normal line is the negative reciprocal of the tangent line slope. So really the only difference for the normal line is that it's a perpendicular line. So instead of being a tangent line, the normal line, okay, is the exact perpendicular to the tangent line and intersects at that point that intersects the graph at that point. Okay, so that's the idea of the normal line. Now, how do we do a negative reciprocal? Well, if you'll remember, m equals, now the negative reciprocal, the perpendicular slope is 1 over m, but it's also, that's the reciprocal, but it's also negative, right? So if I have a slope equal to 5, then the perpendicular slope is equal to negative 1 over 5. Same if I had like a slope equal to negative 2/3, then the perpendicular slope would be equal to positive, it's the opposite, right? The negative reciprocal, negative, negative make a positive, 3 over 2. Okay, so that's the idea, how to get your negative reciprocal. And you go to my slope video in college algebra if you're still having trouble with negative reciprocals. Okay, so the normal line in general is designated by the n, just like the tangent line was designated by the t. The n will tell me that's a normal line, n of x equals the negative reciprocal of the slope. So I take the f prime of c, evaluate at the point c, right? And then I do the negative reciprocal, that's where that negative 1 comes into play. And then I multiply by the x minus c and plus the f of c. So literally the only difference between these two equations, the normal and the tangent line, is their slopes, the negative reciprocal of each other. Okay, so this is the graph of the normal line to f of x at the point x equal to c. Now, we've got a situation here. If f prime of c is equal to 0, so you think about this scenario, right here. When we plugged in 0 for x, I got a horizontal line, right? Now, the normal line, instead of the tangent line, would be perpendicular. It's vertical. So you can't write a vertical line as a y equals something, right? It's actually defined to be x equals. Okay, so let's back that out, and we'll see that if we have f prime of c equal to 0, I don't write negative 1 over 0. That's undefined, right? I call that equation of the normal line x equals c, okay? Just like here, the normal line here would be this vertical line, x equals 0, okay? That's the equation of the normal line there. So that would be the one scenario you'd watch out for so that you're not dividing by 0 in your formula here. Okay, so let's take the problem x squared plus 5. Okay, so remember we found the derivative f prime of x to be 2x. Okay, so we know the derivative is 2x. So if I evaluate f prime of 3, that's 2 times 3, which gets me the 6. And if I want to do the negative reciprocal here, that's negative 1 over 6. So if you think about it, your negative reciprocal here, you can go right from here to here, okay? And you get the negative 1/6, okay? So that's your slope, that's one part, but the other part you need is your f of c. So f of c, c here is 3. And so we got that from our problem up here, 3 comma 14. That was what was going on there. The 3 comma 14 was the point. The x value is 3. The y value is the 14. Okay. And so that's where this information comes from. And so what does that tell me? Using my formula, the slope is equal to negative 1/6 times x minus c. Well, c here is 3. And then add f of c, and f of c was 14. Now, if you want to, you could clean this up a little bit, distribute the negative 1/6 through times x, and then times the negative 3 here, and simplify, collect like terms. You get the normal line of x is equal to negative 1/6 x plus 29 over 2. And that's your final answer. Okay, so hopefully that helps you kind of understand the normal line. I did this in a separate video because, may decide later that we don't want to use the normal line, but there are homework problems over finding equation of the normal line.